Your skin is not a uniform barrier but a dynamic organ with a unique self-repair system. When you get a cut, a cascade of events begins immediately, driven by your body's need to protect you. Within seconds of an injury, platelets in your blood rush to the site. These cell fragments are not just for clotting, they release signals that summon reinforcements. This signaling initiates an intricate biological response, one that has evolved to minimize the risk of infection and blood loss. The marvel lies not just in healing, but in how this process begins with such precision and speed. The catalyst for this healing process is a protein called fibrinogen circulating in your bloodstream. When activated by enzymes from the damaged cells, it transforms into fibrin. Fibrin acts like a net, trapping blood cells and forming a clot. This clot is your body's temporary patch, preventing further blood loss and serving as a scaffold for the repair. Over the next few days, your body will replace this scaffold with new tissue. This fibrin netting is not just a plug, it is a blueprint for reconstruction. An invisible web that guides cells to mend your skin's breach. But how does your skin know when to stop rebuilding? Enter the role of growth factors, tiny proteins released by platelets and nearby cells. These molecules are like microscopic coaches instructing cells to divide, migrate, and specialize. As the wound closes, the levels of these growth factors diminish, signaling cells to slow down. This feedback loop prevents excessive or unchecked growth, maintaining the integrity of your skin. It's not just about healing but healing with precision, ensuring your skin returns to its original state. A delicate balance orchestrated by molecular whispers. Beneath the visible surface, your immune system plays a crucial role. White blood cells, particularly macrophages, swarm the wound site. These cellular janitors clear out debris and pathogens, preventing infection. They don't just clean, they also release signals that aid in tissue repair. Macrophages are pivotal during the transition from inflammation to tissue formation, ensuring that the healing environment is optimal. The transformation of your wound into healthy skin involves a symphony of cellular activities where even cleanup crews have dual roles in defense and healing. As the healing journey progresses, a remarkable process called remodeling occurs. Collagen, a structural protein, is laid down in a haphazard fashion at first. Over weeks, this collagen is meticulously reorganized, aligning along tension lines and restoring skin's strength. This phase can last up to a year, during which the scar may change in appearance and feel. The skin's ability to remodel itself showcases its resilience and adaptiveness. Despite the initial chaos of healing, your body strives for perfection, constantly refining the repair to mirror the original skin. Deep within you, cells called keratinocytes step up after a cut. These skin cells originate from the basal layer of your epidermis. They migrate towards the wound, crawling over the newly formed tissue. Keratinocytes proliferate rapidly, covering the wound with a temporary seal. Their journey is guided by a subtle electrical field generated by the injury itself. This bioelectric signal acts like a beacon, directing cells to the breach. It's a cellular migration that's both guided and relentless, ensuring that your skin is covered as soon as possible. The process continues until the keratinocytes meet, sealing the gap. Underneath the surface, fibroblasts are hard at work. These cells are the architects of your skin's structural framework. When activated by growth factors, fibroblasts migrate into the wound bed. They produce collagen, the protein that gives your skin its tensile strength. But fibroblasts don't just build, they also communicate, sending out chemical signals that coordinate the repair process. Their activity is crucial for laying down the new extracellular matrix. This matrix acts as a scaffold, allowing other cells to move in and complete the repair. It's a complex assembly line, ensuring your skin regains its form and function. As healing progresses, angiogenesis begins. This is the process of forming new blood vessels, vital for supplying nutrients and oxygen to the healing tissue. Endothelial cells, which line blood vessels, sprout and extend into the wound. These cells respond to signals like vascular endothelial growth factor, which guide them to form tubular structures. The creation of these new vessels ensures that the tissue regenerates efficiently. Without this vascular network, the healing process would falter. Angiogenesis is a testament to your body's ability to rebuild and restore, creating lifelines that sustain new skin. The role of proteolytic enzymes in wound healing is pivotal. These enzymes, such as metalloproteinases, degrade damaged proteins and tissues. This cleanup clears the path for new tissue to form, preventing the accumulation of debris. They also regulate the activity of growth factors, modulating the healing process. Proteolytic enzymes are intricately controlled to prevent excessive tissue breakdown. Their activity is a balancing act of destruction and creation. By sculpting the wound environment, they ensure that healing is orderly and efficient. This enzymatic activity is like a finely tuned orchestra, harmonizing the repair. Nerve cells also play a part in wound healing beyond transmitting pain signals. After an injury, they release neuropeptides that influence nearby cells. These molecules can stimulate blood vessel formation and fibroblast activity. The interplay between nerve cells and the immune system is crucial. Neuropeptides modulate inflammation, reducing excessive immune responses that could delay healing. This communication network ensures that the repair process remains on track. It's a testament to the body's interconnected systems where even pain pathways have reparative roles. Nerve cells guide and guard the healing journey, underlying their complexity. When your body is under stress, healing can be compromised. Chronic stress elevates cortisol levels, a hormone that suppresses immune function and delays wound repair. Cortisol can reduce the proliferation of fibroblasts and keratinocytes, slowing the reconstruction of tissue. Moreover, stress-induced inflammation can lead to excessive tissue damage, creating additional hurdles for your cells. This shows how interconnected your mental state and physical healing are. Under continuous pressure, your body reallocates resources, prioritizing survival over repair. Understanding this connection highlights the importance of holistic health in recovery. Stress can transform a simple cut into a prolonged struggle. Sometimes the healing process can go awry, leading to conditions like keloids. Keloids are overgrowths of scar tissue that extend beyond the original wound boundaries. This occurs when fibroblasts produce collagen in excess, unchecked by normal regulatory mechanisms. Keloids are more common in certain genetic backgrounds, affecting up to 16% of people with African, Asian, or Hispanic ancestry. The exact cause remains a mystery, but they reveal the fine line between healing and overproduction. These scars remind us of the complexities underlying tissue repair. Each keloid tells a story of cellular miscommunication, where the body's attempt at healing outpaces its controls. Your skin's ability to heal is not limitless. In severe burn injuries, the damage can be too extensive for normal repair processes. The destruction of skin layers impairs the migration of keratinocytes and the formation of a collagen scaffold. This can lead to chronic wounds that never fully heal, posing a risk of infection and fluid loss. Such wounds often require medical interventions like skin grafts to restore integrity. It underscores the skin's role as a barrier and the challenges when that barrier is breached beyond its repair capacity. These extreme cases highlight both the strength and vulnerability of our skin. Consider the remarkable case of salamanders, which can regenerate entire limbs. Humans, while lacking this ability, have shown regenerative potential in certain scenarios. The liver, for example, can regenerate from just 25% of its tissue. Researchers are exploring ways to unlock similar regenerative pathways in human skin. Studies have identified genes associated with limb regeneration in animals, raising the possibility of future medical breakthroughs. This research could revolutionize healing, transforming how we recover from injury. While your skin's healing is impressive, the potential for enhancement opens exciting frontiers in medicine. Regeneration may one day be more than science fiction. One stunning truth about your skin's healing is its resilience over time. A study from Nature in 2021 found that skin cells can repair DNA damage from UV exposure, a mechanism that persists even with aging. These DNA repair pathways help prevent mutations that could lead to cancer. Despite environmental challenges and age-related decline, your skin continually adapts. It's a testament to the evolutionary refinement of healing processes. This ability to mend at the molecular level reframes how we view our skin, not just as a passive barrier but as an active, vigilant organ. Your skin is constantly in a state of renewal and defense.